Right, we are picking up on 10-4, which is what we started yesterday. You need to have your z-score table out with you. So everybody got their z-score table. Okay, so we did examples 1 through 4 yesterday. We're going to start with example 5 today, and we're just expanding on what we already know. Yesterday, we looked at everything that was, all of our questions was, what's the percent, what's the probability that it is less than? And so all you had to do was read your table, okay? Today, we're going to be looking at less than, and then we're going to be more specifically looking at what is more than, okay? So here we go. Let's start with example 5, kind of a warm-up from yesterday. Suppose that a data set is normally distributed with a mean of 20 and a standard deviation of 5. I want the probability that a random value selected will be less than 19. So can you draw a bell curve? Yes, let's do that. So we're going to draw the bell curve. 0, 1, 2, 3. -1, -2, -3. Mean is 20, and we have a standard deviation of 5. So what would this be? 25, then 30, then 35. Over here we have 15, 10, 5. I want the probability that it would be less than 19. So let's mark 19. Is this one good by the table? And we want everything that is less than, yes? We want all of this. Is this one good just by the picture? Is it exactly on it? No. Okay. I mean, we know it's going to be close to what? Close to 50. Why? Because it's almost at the 20, right? We know, like, how much percent's on the left side of the mean? 50%, and then there's 50% on this side. So you know it's going to be a little less than 50, okay? But we don't know exact. So I'm going to hit the pause button. I want you to take 19, turn it into a z-score, use your table, and give me the percentage less than, okay? How would I fill in the formula? 19 minus 20 divided by 5 is going to end up being what? Negative 0.2. Everybody agree? But I need it rounded to the nearest hundredth. So what do? I need 2 decimal places. So what goes out there? A 0. Okay, if there's nothing else out there. So on our z-score table, we're going to be on the negative side. We're going to go down to 0.2, negative 0.2, all the way at the bottom. And we're going to go across to 0, which is all the way on the other side. Okay, so what percent? All right, so we know that it is 0.4207. Now, we know that's 42%. Does that make sense? Because what did we say it was going to be? We knew it was going to be slightly less than 50, right? And so 42% makes sense, okay? So here's my question. Do we want 42% or do I want 0.4207? What's the question asked for? Probability. So I want what? The decimals. So 0.4207. Okay? All right. Let's go to part B. My question now says, what's the probability that it will be more than 19? So I'm going to shade more than 19. So we want this side this time. We know it's 42.07% less than. How can I figure out what's on the right side? 100 minus 42.07. Okay, so here's let me tell you this. If you're going to do it with percentages, you're going to subtract from what? 100, right? If you're going to use 42.07, and most people feel comfortable with percentages, okay, 42.07, you're going to subtract from 100. If you're going to use the probability, the decimal, what would you subtract from? What's it out of? One whole. So you could, if you wanted to, I don't know, you guys tell me which one you want. Do you want me to move it to a percentage, subtract it from 100, and then move it back to a probability? Or do you just want to take this probability and subtract it from 1? Huh? So just take this and subtract that from 1 whole. Do you understand the difference? If you're going to do, don't mix the two up. If you're going to do the probability, you subtract it from 1. So what's 1 minus 0.4207? 0.593. Okay? And that would be the answer to this one because it's the probability. Okay? If they said the percentage, then it would be how much percent? 57.93%. And that makes sense. No, we did, because that was in the decimal form, we did 1 minus 0.4207. If you're going to do it with the decimal, you subtract it from 1 whole. You with me? If you're going to do it in terms of percentages, then you subtract it from 100%. Because that's, if you take 1 and make it a percent, move it 2 places, it's 100, right?
Yeah.
Okay. I did do 1 minus 0.4207.
Oh, it really does.
And it really does give you 0.5793. Because it's 1 whole. Because this is 0.42. Okay? Now, listen. If it makes more sense to you, some people struggle with decimals. If it makes more sense to you to make that a percentage and say this is 42.07%, and then subtract that from 100, that would be just fine. You would get 57.93%. But then, if the question says the probability, you have to move it back and make it 0.5793. Okay? It just depends. How many of you want to make it a percentage and subtract it from 100? How many want to just leave it in the probability and subtract it from 1? Okay. And so, just make sure you don't confuse the two. What would be really bad is if you made this, if you took the 0.4207 and subtracted it from 100. That would be confusing the probability with the percentage, and you don't want to do that. Okay? Yes? Yes. All right. So let's look at example 6. Suppose that a study of how long it takes students to complete an exam has a mean of 80 and a standard deviation of 8. What percentage of the students took at least 90 minutes to complete? What is at least 90? If you took at least 90 minutes to do something.
That's an hour and 30.
So it's an hour and 30 or less, or an hour 30 or more? If you took at least.
Oh.
At the least. So at the least.
So
It could be more that you took.
right, it could be more. So I want 90 or more, correct? So I want you to draw your bell curve, and I want you to shade, mark 90, and shade more than 90. And then I want you to turn it to a z-score and figure out the percentage that is more than. Number one mistake is people will just put in 90. Hold that thought, and I'll get to you. And they'll just put it in the table, and they'll just say, that's my answer. Because you're just plugging and chugging numbers. Like when you just put it in the table, listen, when you just put it in the table, what percentage do you get? 90% or 89%? Will 89 be a choice on the test? And if you're not paying attention, what will you choose? 89. You have to, that's why I say shade. Because let me ask you this. Johnny's back there using his CS brain, and he's saying, okay, this is 34, and this is 13.5, and this is 3.25, and this is common sense, and this is 0.1. Here's my question. How much, if we came out with 89%, because that's what the table gives us, correct? Well, my question is have we shaded 89%? How much is 89%? Almost the whole thing. Any questions? That, like, the shading's going to help you. Obviously, you know this has to be less than half, correct? Why did we, because we want, the question says more than. We want 90 or more, correct? Okay, so I want to make sure we're shading what the question's asking for, okay? So if you make this a z-score, we're going to put in 90 minus the mean, which is 80, divided by 8. So what do you get when you work this out? 1.25?
90 minus 80 is
okay. And so if you use 1.25 on here, you get 89 point what? 44? But here's my question. Hold on. Where's 89.44? Over here. 89.44%. So my question is, how do you get what's over here? You subtract that from 100. So it would be, what did y'all say, 10.56? All right, Brandon, what's your question?
That was me that had a question. So 90 minus 80 is 10, right?
90 minus 80 is 10.
Okay, divided by 8.
Divided by 8.
1.25.
Right.
Now what do you do with 1.25?
You go to your Z table.
Okay. All right, so
You go down to 1.2. And that's 89.44%.
And then what? Then how do you?
That's what's on the left side. Because that's what the table gives you less than. Okay, repeat after me. Table gives you less than.
Write that down, guys. This table gives less than.
Table gives you less than. I hope Miss Heady's class is saying this with me too. Table gives you less than. Table gives you less than. Table gives you less than.
Right, now on to my question.
And then you take this to get on the other side and subtract it from 100.
So you do 89.
You do 100 minus 89.44.
That's a lot of
Okay. All right. Here we go. Let's try this one. Okay. The weight of an adult male greyhound dogs are normally distributed. And when it says normally distributed, the mean weight is about 68 pounds and the standard deviation is about 10 pounds. What percentage of adult male greyhounds would expect more than 90 pounds? So, I want you to draw your bell curve. I want you to find your z-score, use your table, and find me what's the percentage, not probability, that it's more than 90. And then go ahead and answer part B. Find the percentage that they would weigh less than 45. So 2 questions. Okay? All right, I'm going to hit the pause button. You go to it. All right, what is 90 minus 68 divided by 10?
8 is
What's the z-score first? What's the...
2.2.
Everybody agree with 2.2? Is it 2.2 even?
No, yes.
Like, what's the hundredth?
2.2.
This would be 0. Okay. So 2.2, 0. It would be how much percentage?
0.9861. But then you want to move that decimal point 98.61%.
So, but number one mistake is people, because you will see this answer, 98.61 on the test. Okay, and I don't want you to be like, man, I almost had it, I just messed up. Because that will be an answer. Don't stop there. Where's 98.61%?
All on there.
Where? That's less than. That's this side. So my question is, you have to subtract it from 100, so what percent would be greater? 1.39%. Very good. Okay? 1.39%. Okay? So then, let's mark 45, which would be over here. And we want, the question says less than. So I'm going to shade. So before we even start, is this going to be a big percentage or a small percentage? Well, small, because we haven't shaded very much. That's going to help you, like, catch if you make a mistake. Okay? Okay, so we're going to do 45 minus 68 divided by 10. And that gives us negative 2.3. What's the hundredth? 0.
So then it's 0.84%.
You have to be careful because on the negative side, where's 0? Up top.
Oh, on the back.
On the far side. So it would be 0.0107. So if we moved it, it would be 1.07%. Here's my question. Do we need to subtract this one from 100?
No,
Why?
because it's less than.
And what gives you less than? The table. The table gives you less than. Okay? So this answer would be 1.07%.
So then why did we subtract 100 from the first one?
Because that says,
Because it wanted
More than.
more than.
Okay, that one's less than.
Yep.
Is that one probability? Or is that
They're both percentage. Probability, if I wanted the probability of this, I would just move it back. It would be what you have on the table.
So it would do the same steps, just stop at the table.
Right, you wouldn't have to move it. So it'd be 0.0107. That would be the probability. All right. So we're going to stop there for today.